Hello, welcome to this video where I'll cover the slope-intercept form of a line and things related. So the topics covered will be that slope-intercept form, slope of a line, graphing lines, point-slope formula, slope formula in general, parallel lines, and perpendicular lines. So I'll start off by giving you all the formulas in one place. So these are formula reviews. So the slope-intercept formula is y equals mx plus b. This is where m is the slope and b is the y-intercept. Point-slope formula uses a point and a slope. Here we have y minus y1 equal to m times parentheses x minus x1 and in the parentheses. So in this formula, x1 and y1 is a given point. M is the slope. The generic x and y stay open as far as solutions to the line. Slope formula here. M is what we've been calling the slope, and that'll be equal to the fraction where y2 minus y1 is in the numerator. Y2 minus x1 is in the denominator. Sometimes this is referred to as a change in y over a change in x. What's important is that the x2 and the y2 come from the same point, so that leads off. And following from the subtraction, the x1, y1 come from a separate point. So we need to keep those points and those positions lined up. Okay, and that will give us the rise over run or the change in y over change in x that you may be familiar with. So we want to talk about reading and graphing slope-intercept. So here's an example, just very simple. Y equals 2/3 x plus 3. This is already in slope-intercept form, so we can understand that m, or the slope, is 2/3, and the y-intercept is 3. So what does this mean? Over on the right, I have a graph. Y-intercept of 3, this is probably the first thing that would help you graph. So we go to the y-axis and we go up and we put a point at 3. Okay, and then the slope is 2/3. So what we would do from there is we would go from the 3 and we would go up 2. So now y is 5, and we would go over 3 to where x is 3. So we'd also plot the point 3, 5. And then we can make a straight line through these 2 points, because everything we're making here is straight lines. So 2 points to find a straight line. We can get 1 point from the y-intercept, and the other point we can get by moving the slope, the y over the x. Okay, so now we want to say we don't start off with a great equation for a line, so we want to write it. So this will use the point-slope formula. So my question here is write the equation of a line with a slope of 5 and through the point 2, -3. So if we're going to use the point-slope formula, we know m is 5, so that's the slope, and because our point is 2, -3, x1 is 2, y1 is -3. So we're going to fill in the point-slope formula, y minus -3 on the left equal to 5 times the quantity of x minus 2. We'll use distributive property, collect like terms, get y by itself because that'll give us slope-intercept form. And we'll have y equals 5x minus 13. So in this form, the slope is still 5, but the y-intercept is -13. So I have a graph over to the right where it's kind of zoomed out so you can see the whole line. But you see the y-intercept down there at around -13 on the y-axis. And then if you move up 5 over 1, for the slope of 5, you see the other point, connect them, you have a straight line. Alright, so here's another example, except we're going to start off with 2 points instead of having a slope. So we're going to write the equation for a line going through the point 4, 1 and the point 2, -3. So if we let 4, 1 be our first point, 4 is x1, 1 is y1, and our other point 2, -3, x2 is 2, and y2 is -3. Okay, so we're going to use the slope formula. Remember the m equals the fraction where the numerator is y2 minus y1 over the denominator of x2 minus x1. So this fraction, when we plug in these points, will be negative 3 minus 1 all over 2 minus 4. So this gives us, when we do the arithmetic and clean up this fraction, a slope of 2. So now we go to the point-slope formula, and m is going to be 2 from our slope, and we can use either point that was given to us, but since we've already labeled 4 and 1 as y1, x1, we'll plug those in. So we plug in the point-slope formula, we'll get on the left y minus 1, and on the right 2 times the quantity of x minus 4. We'll distribute and clean up till we get to slope-intercept form, which is y equals 2x minus 7. So over on the right I have the graph, and I have the points 4, 1, and 2, negative 3 graphed, which are 2 points which would give you a straight line. So if you were just graphing, you really wouldn't need anything else. But for the equation, you can also see I have the negative 7 for the y-intercept, and the slope of 2 seems to hold if you move off of that point. So all three of those points, the y-intercept and the two given points, end up on the same line. Okay, now we want to talk about parallel and perpendicular lines. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So that sounds kind of weird, but the best way to remember this is that if your slope is a fraction, such as a over b, the perpendicular slope will be negative b over a. So it will change the sign and it will flip the fraction. And even if you have a whole number, you could write it over 1 and consider it a fraction. So let's go to some examples. So parallel lines. So given the line y equals 2x plus 3, write the equation of a parallel line going through the point 1, 2. Okay? So parallel lines have the same slope, so we're trying to write a line parallel to y equals 2x plus 3, so we want to use the same slope, which is 2. So the line that we're going to create has a slope of 2. Now we also want to go through the point 1, 2, so x1 would be 1 and y1 would be 2. So we're going to use the point-slope formula, and on the left we'll have y minus 2, and that'll be equal to, on the right-hand side, 2 times the quantity of x minus 1. Okay, clean that up, isolate, we get y equals 2x. There's no y-intercept there, so it means the y-intercept is 0. So if you look at the two graphs on the right, you can see the actual problem kind of worked out. So the top graph is y equals 2x plus 3. That's the line that was given to us, and you also see the point 1, 2. So that was the given information, and what we're trying to do is go through that single point and make a line parallel to the one that was given. And after we did the calculation, I added that line in the bottom graph, and you can see the two lines are parallel. They never touch. Perpendicular lines. So here I'm going to use the same equation and point. Perpendicular to y equals 2x plus 3, but going through 1, 2 again. So that first equation has a slope of 2, but remember perpendicular lines, if I want to have the perpendicular slope, I need to treat that as a fraction, change the sign, and flip it. So the perpendicular line will have a slope of negative 1/2. Now x1 is still going to be 1 and y1 is still going to be 2. So I'm going to plug that into the point slope formula. This will be y minus 2 equal to negative 1/2 times the quantity of x minus 1. And we're going to clean that up to get y equals negative 1/2 x plus 5/2. And over on the right again, I have the y equals 2x plus 3 line and the point 1, 2 to show you the setup. We're trying to go through that single point and create a 90-degree angle when we hit the original line. At the bottom, I put in our y equals negative 1/2 x plus 5/2, and you see how they run into each other perpendicular at a 90-degree angle. All right, here's a couple of practice problems. There's 4 of them. 1, write the equation of a line with a slope of 2/3 and through the point 4, -3. The second one, write the equation of a line through the points 2, 5, and 4, -3. Problem number 3. Given the line y equals 3/4 x minus 4, write a parallel line through the point 1, 2. And 4, given the line y equals 3/4 x minus 4, write a perpendicular line through the point 1, 2. If you're going to do these, pause. The answers are on the next slide. I'm getting ready to go there, so pause, work them out, and then come on over. So the first one, y equals 2/3 x minus 17/3. Number 2, the answer was y equals -4x plus 13. Number 3, y equals 3/4 x plus 5/4. And number 4, y equals -4/3 x plus 4. All right, thank you.